All right, guys. Well, we just in the Google Meet reviewed a little bit about some of the examples and laws that we got the other day about like adding, multiplying, all that stuff with exponents. And because of what was going to be coming up, I said, hey guys, let's do a little bit of work with fractions because fractions is coming up today. And so let's go ahead and just start getting notes. I don't think today's lesson is going to be too long, but 8.2 is called radical expressions and rational exponents. So radicals, we should know what a radical is, right? A radical is that square root symbol right there. Okay, so that right there is just a plain old radical. And so we have radical expressions. So we're going to be seeing radicals, but then we also want to make them into exponents. And today's lesson and homework hopefully will go pretty quick. When the homework posts, some of you might freak out because it's like over 20 problems. But I'm telling you, if you watch this video, the first 8 problems and then the second 8 problems should honestly take you looking at them and then write them down on your paper and you're pretty much done. So make sure you're paying attention enough to this video to be able to do that part that quick. Okay? We are going to take radical expressions. So we're going to see the square root symbol or whatever. It's not always going to be a square root. And we're instead going to write it as a rational. And remember, rational means fraction exponent. So we're going to start with radicals and we're going to write them as fraction exponents. And then we're going to go backwards. We're going to write fraction exponents and write them as radicals. Guys, it's very, very easy. I know it sounds confusing, but it's very, very easy to go back and forth on this. So once again, if you remember, a radical is usually what I would say when we saw like this symbol. But I was kind of lying to you a little bit because sometimes there could be like a number written in that radical, right? So you don't need to add that to your notes if you don't want, but this next thing is going to be important for you to write. Okay? So right here, we have this radical, and I just said there could be a number written right there. So right in front of this blank radical symbol, I would like you to circle that value right there, which is blank right now. That is what we call the index. Guys, it's going to be very important that you know whatever number is hiding right here on a radical is what we call our index. So I just wrote a few radical symbols right here. They all just have X underneath them. It's a little bit of a trick. We would call this one the square root. So since we call that one the square root, what number is actually hiding right there? And so underneath this, would you please write index equals 2. All right, it's very important to know that our index on that first example is 2. This one, it's already written there. What is our index on this example problem? Perfect. Index is 3. And that last example problem, perfect. Index is 8, right? Pretty easy to figure out what the index is. Hopefully so. If you're following along with me right now, this is why it's going to take not very long at all to whip through your homework. All right, exponent, I don't even have to really talk about the exponent. The exponent is when we have a power. So again, I wrote a few examples here. Our exponent right here would be 3. I barely even have to write this down. I just have to say it. This would have an exponent of 3. This would have an exponent of 5. This would have an exponent of 8. All right. So what happens if we get a crazy mixed up everything going on at once? So I'm going to hold up this paper real quick. And guys, right now, who sees a whole bunch of radical symbols? Okay? Because you see a whole bunch of radical symbols, the directions for this part of the homework, I actually should have put this, should have said, change from radical form to rational exponents. That's what the homework is going to say for this. But right now, since we see radicals, we just need to write it in the opposite form. We see radicals, we need to write it in the opposite form. Now you look at this and you're like, oh my gosh, this is crazy. There's so much going on, so let's back off and let's take a little bit of a break, okay? In just a minute, I'm going to put that back up. So don't worry if you didn't get it yet. I'm going to put that back up and you can kind of pause and we're going to work through most of them. How do you change back and forth? So I kind of have the answer here, so you might be able to see through. I kind of don't care. All right, so here are some important things to know. Just a second ago, we talked about how that radical symbol always has an index on it. We can look right there for an index. We are always going to have some sort of base, okay? Our base, just so you know, does not change. Never, ever, ever change the base. I mean, these other numbers don't change either, but you just kind of change how you write them. And then we have our exponent on our base. So the exponent is going to be underneath the radical. That's the thing that's going to be kind of weird. So we're going to have most likely have an index. That's the number written in the little radical symbol. And then underneath the radical, we have our base to some exponent. Well, guys, like I said, I didn't want to totally give it away, so I was holding that there. Here is how you change it, and I color-coded this just to help out. The base stays the same, but you get a new exponent that happens to be a fraction. And the fraction is going to keep the exponent in the numerator, and you write the index in the denominator. So it's really weird. Our answer is going to have a base, but then our exponent is going to be a fraction. This right here is very, very, very important to write down. So pause my video and take as long as you need to make sure that you get this written down. Guys, that should give the answer away to this worksheet that I held up before. And again, you're going to pause now and please write all of these down. And if you think you already know how to get the answer, that's fine. But pause it, and then I'm slowly going to work my way 1, 2, 3, 4. Okay? So if you would write these down, please. So pause. All right, hopefully you wrote them all down. Let's look through each one. And again, I'm going to use the same colors I did before to color code. I'm going to circle the 4. The 4 is the index, so I'm going to call that I. I'm going to circle the 3. That's my exponent, so I'm going to call that E. And that's the paper that just fell on the floor here. So if you guys give me a second, remember my index was pink, my exponent was blue. I kept the same base, but I made the fraction of exponent divided by index. So since I decided my exponent was 3 and my index was 4, the answer for this first example problem would be x stays the same. The exponent is going to be 3/4. Okay, and so it kind of looks weird there the way you write it, because it looks like really, really strange. Oh, by the way, guys, the other day when I was grading some people's homework, it was really hard to read when you try to squeeze it in and go all sorts of places. Make sure you write it big enough that I can see it, because there's some of you, when you get your answers back, I even wrote, I can't tell what this says. So please be very careful when you're writing that. All right, we're going to go across the paper on mine right here. So if you would please look at this example. The index is the, thank you, 10. The exponent is the perfect 7. Keep the base the same. The base is 2. My exponent was 7, so keep that in the numerator. So 2 to the power of 7/10. I'll hold up my paper in just a minute. The next example problem. Index is 8. Exponent is 3. And my base was 5. Answer is 5 to the power of 3/8. Right? See how fast these go? So that's why I hope you're not worried about the first few problems. All right, guys, this is the first checkpoint for today. I know the other day I said sometimes we'll have checkpoints, sometimes we won't. You right now need to hit pause on your video and click back over to the live stream and answer this problem for me. You're going to say, hey, Miss Jabs, I'm to the first pause point. I'm going to tell you the answer to this as a rational exponent. Okay, so your first checkpoint back in with me to make sure things are going okay is to tell me what is this answer as a rational exponent. So pause, go on over to the live class feed, meet, and talk to me there. But after you come back, what happens if we actually have to go backwards? Okay, so if you look at this, it looks like all the answers you just wrote, but we're supposed to write it as radicals. So just as a reminder, and I didn't quite write this all here, in the numerator is the exponent, and in the denominator is the exponent. Where does the exponent belong? On the base. Where does the index belong? In the little check mark, right? In the little radical. So whatever is in your numerator stays as the power on the base. Whatever is in your denominator goes out to your index. Now, one index that is weird. If we would get an index of 2, that would be the square root, and usually we don't see the square written there. And so please make sure you don't write the square there. Same thing would be true if your numerator is 1. We don't always write anything to the first power. So go ahead and pause and write down the examples. You don't have to write the originals, the problem yet, excuse me. All right, so look at number 1. I'm going to go a little bit slow on the first example. Remember, whatever is in our numerator is our exponent. Whatever is in our denominator is our index. And so right here, if I circle like this and remind you the first time, our exponent is going to be 5. Our index is going to be 8. So I have to write a radical symbol. Remember, once I write the radical symbol, inside the radical symbol goes my index, and so I'm going to write a tiny 8 inside that radical symbol right there. The base stays the same. The base is still x, and my exponent is 5. So the 8th root of x to the 5th would be the answer for that first one. Second one, what's my exponent? Oh, there it is. We don't have to write an exponent of 1. What's my index? 3, thank you. So for this answer, since the exponent was 1, I actually have an exponent of 1 there, we just don't write it, and the index is 3, so that one would be the cube root of 4, and we would leave it that way. Next one, those numbers are big, who cares? What's your exponent? What's your index? Very nice. And so you would get the 13th root of 7 to the 10th. I don't even care what that is. Don't use your calculator to find out what 7 to the 10th is. I want the answer left this way, so I know you know how to go back and forth. So guys, guess what? I know it wasn't that long ago that you checked in, but guess what's going to be true about that one right there? You're right. Pause your video. Click over to the live feed again and say, hey, Miss Jabs, I see how quick this homework is going to go, because the first 16 problems are just switching back and forth like I just taught you how to do. Now, once you come back to the video, that wasn't the entire homework. There's a little bit more. I want to make sure we know a few things, and that's why I practiced adding fractions with you. Guys, what if we had to do a problem like this? So from a few days ago, we noticed that if we want to do this, we should add our exponents. But as a reminder, at the beginning of class, I said, hey guys, let's do a little bit of work with fractions when we were all together as a live group, because we have got to make sure that these exponents have the same denominator. Right now, they don't. So off to the side, I'm just going to think, how would I add 1/3 and 1/5? Only if they have the same denominator. What denominator do I think 3 and 5 should have in common? Thank you, 15. So to get 15, I've got to multiply my 1/3 by 5 over 5, because that would get me 3 times 5 is 15. And I've got to multiply my 5 by 3, which means I need to do 3 over 3. So let's look at this one. What's 5 times 1? And what's 3 times 5? Right? Everybody agree? 5 over 15, excuse me. On this side, I would do 1 times 3 and 5 times 3. So I would get 5/15 plus 3/15, which would equal 8/15. And so remember, I'm supposed to add the exponents right over here. I added. My answer is going to be x to the 8/15. But on the homework, I said I really want to make sure we know how to go back and forth. And so we're also going to write that as, that one's an exponent. So now we need to write the radical. What is the exponent still going to be? Good. The numerator, remember the numerator is the exponent, and the denominator is the index. So your answer would be both x to the 8/15, and you could write an equal sign there because they're the same, 15th root of x to the 8th. So guys, very last thing you get points for, and then the homework will be posted. Write down this example, click back over to live, and work through it with me, and then you can work on the homework for the day. Thanks. See you on Meet.